We've already seen exponents come up previously in the LCM, GCF videos, as well as prime factorizations. So today we're going to go into exponent rules, and the goal is to get you guys comfortable, and this will be a whirlwind tour through all of the common exponent rules you will encounter, and I want you guys to feel pretty good about them after today. Now there'll be subsequent videos with more practice examples, but for now the goal in all the stuff will be to understand and not memorize. So do not try to memorize these rules. All of them should be fairly intuitive except for maybe a handful of them. So that's the goal here. See if you can understand why they work. So we're going to go down the list. Now these are numbered 1 through 5 because I want to focus on these. These are not really extra rules. These are just some applications of combining these other rules. And in fact, you don't even need all of these rules, and we'll see what I mean in a few seconds. So let's take a look at rule number 1. And these are just letters, but this could be numbers. So 2 cubed times 2 to the 4th. So the rule says you add the powers, b plus c, so this would be 2 to the 7th. Now I don't want you guys to remember this, so why does this work? What does 2 cubed mean? The cube means we have 3 2's multiplied. So this is 2 times 2 times 2. Thank you for the music, guys. All right. Then 2 to the 4th means we have 4 2's multiplied. So altogether, how many 2's do we see? There are 7 2's, so that's why the rule gets us 7. We are literally multiplying 3 2's and another 4 2's, so altogether there are 7 2's. So don't memorize when you see this add the powers. Just understand that's what it means. This is what you're actually doing. All right, so that's rule number 1. Rule number 2 says the opposite. If you're dividing terms, then you're going to subtract the power. So if you have 2 to the 4th over 2 cubed, this would be 2 to the 1st. You subtract the 4 and the 3. Again, why does this work? All this says is there's 4 2's. This means there's 3 2's. So 3 of these will cancel. So you're left with 1 2, which is also known as 2 to the 1st. So that's why this rule is subtraction. You are literally simplifying powers. Okay. Let's go to rule number 3, which is a power to a power. So let's say you have 2 cubed to the 4th. What does this actually mean? It means we have 2 cubed times 2 cubed times 2 cubed times 2 cubed. And each one of these 2 cubes is 2 times 2 times 2. So we have 3 2's over here multiplied, another 3 2's, another 3 2's, another 3 2's. So we have 4 sets of 3. So what is 4 sets of 3? That's 12. So that's the reason you multiply these 2 powers. So don't memorize the rule, just understand what the rule is implying that you're doing. All right, so for these two, I would encourage you probably to just memorize them. Anything to the 0th power is 1. Anything to a negative power means 1 over 8 to whatever the original power was. The negative exponent has nothing to do with negative numbers. So let's say you have 2 to the negative 3rd. This would be 1 over 2 cubed, or 2 times 2 times 2, so that's 1 over 8. The negative just means flip it, 1 over the rest of it. That's it. So some of you might have questions about where does this come from, because we understood where this came from, but these I just said memorize. So I'm not going to go into it in too much depth, but I'll give you at least one reason why these are good definitions. Let's plot some points. So what we're going to do is plot y equals 2 to the x. So this is an equation. Let's pick 2 to the 1st power. What's 2 to the 1st? That's going to be 2. What's 2 to the second? If we plug in 2 for x, that's 4. What's 2 cubed? That's 8. 2 to the 4th, 16, and so forth. So if we are to visualize all this information, let's call this x, and that's y. So we have 1, 2, 3, 4. So 2 to the first is 2. 2 to the second is 4. So this is going to grow really fast. It's going to shoot up. So 2 to the 4th will be somewhere here, 16. But if we go backwards and see what is 2 to the 0th, let's say we don't know this definition, the idea for this comes from, we want this curve to be smooth. We don't want this curve to be going all nicely and then go boop. So we want this to go nicely over here. And in fact, if you were to extend it nicely, you'll see that when this is 0 on the x, you would want this to be equal to 1. So this is really trying to create a smooth continuation so that these things make sense everywhere and they don't jump around erratically. Same thing for the negative powers. If you have a negative power, if we go here, it becomes negative. So we don't expect this to suddenly do that. We expect it to move really nicely this way. So that's a little bit of a motivation for where this stuff comes from. All right, let's go to these. These are not really separate rules. Actually, before that, let's even go over this one. This is not even a separate rule. So what is this saying? A to the negative b is going to be 1 over a to the b. Let's see how these three rules are related. So what is rule number 2? Let's just take this part of it. So we'll just take 1 over a to the c, and we will use this rule. So this can be written as that using rule number 5, right? So we have 1 over a to the c is also known as a to the negative c power. So instead of seeing this, we're going to replace this part in number 2 with this. So let's write as a over b. Instead of doing divided by a to the c, we're going to do that. So what we've done is replace the division by a over to the c power. Using this rule, we've turned this into that. And this means this is now multiplication instead of division. Now, this looks a lot like rule number 1. So what we've seen is that rule number 1 just says add these two powers. So b plus a negative c is just b minus c, which is rule number 2. So we've seen that rule number 1 and rule number 5 get you rule number 2. So a lot of these rules are interrelated. So now let's go to this rule. Let's see why this makes sense. So let's say you have 2 times 3 to the 4th. What this means is we have 4 of these. So if we see how many 2's do we have? We have 2 to the 4th and 3 to the 4th. We have 4 2's, 4 3's. So what this rule says is basically distribute the power to everything. Now oftentimes we will use this rule in reverse. We'll start here and go backwards. So you should be able to go this way and that way on each of these rules. So here's an example of how might you use this rule. Now you could try to calculate this, or you could see that, hey, they both share a power, which is this situation. So let's go this way. So we are going to group them and then apply the power. Why do that? Because these will simplify. So 8 times a quarter is 2. So we will get 2 cubed, which is 8. So the point is, would you rather do 8 cubed and multiply by this garbage, or would you rather do it this way? So that's the advantage of using this rule in reverse. Let's see how this rule can be useful. So again, what is this rule saying? If you have something to the c power, so let's pick numbers. What this means is you're literally going to multiply this by itself 4 times. So that means it's going to be 2 to the 4th, numerators times numerators, and denominators times denominators, times over 3 to the 4th. So that's why this rule works. You're literally applying this to everything. And again, you should be able to go in reverse as well. So let's see an example of where it makes sense to use this in reverse. Let's say you want to do 9 to the 4th over 3 to the 4th. So then instead of first calculating this and then calculating that, we are going to group the 9 and 3 together and then apply the 4th power. And 3 to the 4th is 81. It's 3 times 3, which is 9. 9 squared, or times another 3 times another 3 gets you 81. The point is, 9 to the 4th is pretty hard to do, but this is pretty easy to do even in your head. All right, finally for the last one, this is more of a clarification and not so much a rule. This might be one of those that gives a lot of people trouble, so let's go into what this means. This is more just getting comfortable with the definition. So when you see something like this, so let's say we have 4 to the 3 over 2 power. What does that even mean? So this is a fractional power, fractional exponent. The 2 part of it means root, and the 3 part of it means power. So B will generally be increasing your number or multiplying it, and C will be taking the root. Now sometimes you'll see it this way, and sometimes you'll see it that way. These are just 2 different forms for the same thing. This is not a rule really. This is just saying you might see it like this, you might see it like that. So let's do an example. What is the square root of 4? That's the second root, or the square root. So all of these mean the same thing. The square root of 4 is the second root of 4. Because the square roots are so popular, we don't bother writing the 2. So whenever you see square root, assume it's really a 2. This tells you the root number. But you may also see this as a fractional power, so as 1/2. The 2 and the 1/2 means the second root. The 1 doesn't matter, that doesn't do anything. So the square root of 4 is a 2, so that would be our C being equal to 2. So what's the square root of 4 is 2, and what's 2 cubed? That would be 8. So what we're really doing here is doing 4 to the 1/2 first, and then cubing it. Now what allows us to transform this into that? It's the power to a power rule, because you're going to multiply the 1/2 by the 3, and that returns you back to 3 over 2. So let's just do a few problems and see if we can get comfortable with this. So let's do 8 to the 1/3. You may also see this as the cube root of 8. Now what this means is which number times itself 3 times, not times 3, but times itself 3 times gets you 8. That will be 2, because 2 cubed is 8. So let's try 16 to the 1/4. This is saying which number times itself 4 times gets you 16, or what's the 4th root of 16? So you may also see this way. I'm just writing it again so you could see these are all the same thing, and that would again be 2. Let's try 27 to the 1/3. This is saying which number times itself 3 times gets you 27, or you might see it as the cube root of 27. That will be 3. So let's try another one. What is the cube root? The 3 means cube root, not square root, of 125. That would be 5. You might also see this as 125 to the 1/3. So that's what this is meant to get across, that you may see it in this shape with the square root and the root number, or you may see it as a fractional power. So let's do something where the b is not 1. So let's say 16 to the 3/4. So we're going to break this up. We could think of it this way. So this is 16 cubed, and it's the 4th root of it. Now, should we do this first or should we do that first? Well, I'm lazy, so I'm going to do this first because I don't feel like multiplying 16 by itself 3 times. So which number times itself 4 times gets you 16? If you said 4, it's not correct. The 4 here means which number times itself, not times 4, is 16. So 2 times itself 4 times gets you 16, and then we will cube the 2. So that will be 8. So in other words, you're free to choose the order of doing the b or the c, the b power or the c root, however you like. So if that felt a little shaky, we're going to do a few more videos where we go practice this some more. All right.